What is up, guys? Mr. B here again, bringing another sweet, wicked, awesome math video. This is the first in my Snap Calc series of quick little rules and calculus, things that might help you out. And I'm going to follow each one of these little quick videos up with a more thorough, longer video. So if you want to get like a better understanding or see a few more examples, you can do that. So in this one, I'm going to take you through the powerful rule. Now, in calculus, when you're learning the derivative, the power rule is like the basis of everything that we do in terms of derivatives. That's always the first thing that we're going to kind of think about and sort of apply in different situations. So the power rule is really straightforward. If you have something that is like an x to an exponent, so that exponent could be a whole number, it could be a negative number, it could be a fraction, which means it's very powerful for doing radicals like square roots and cube roots and things like that. Then the power rule is really our go-to method for that. And it's really straightforward. Basically what we do is we multiply the power by the exponent, and then we subtract 1 from the exponent. So let's give that a shot. Let's see if I can get a little pen here. So we've got a general term here, y is equal to x to the n. So the way I think of it is that this x kind of drops down to the front and multiplies whatever happens to be there. So in this case, it's just a 1, so it's just going to be, n times 1 is n. And then we subtract 1 off the exponent. So we end up with something like this. So y prime, that means we took the derivative with respect to x, and we drop that n down in front, multiplied by the n, like I mentioned, and then my exponent loses 1. So that's my general power rule, and that's probably how you'll see it written in textbooks. N x to the n minus 1. Let's see it in action, and let's actually kind of put it to use. So let's see. So we'll start with this one. Y is equal to x to the 5, and I'm hoping my head's not going to get in the way. So if you look here, that 5 is going to multiply whatever coefficient I have in front, and then I'm going to minus 1 off from that. I'm just going to write this a little bit lower to make sure my head is not in the way. So y prime equals, and then the 5 is down in front, so it's y prime equals 5. We rewrite our x just like that, and then we minus 1 from the exponent, so it becomes exponent 4. So y prime equals 5 x to the 4. I apologize if my head is in the way. Next one, again, the only thing different about this one is we have a coefficient. So when we have a coefficient, we multiply that coefficient. So either 3 times 7, so y prime equals 3 times 7, which is 21, and then we minus 1 from the exponent, so 7 subtract 1, it is indeed 6. And then the last one that I throw a little negative at you, so it doesn't change anything. If we have a negative exponent, we go ahead and we multiply, so we get negative 3 times negative 4, that gives us positive 12. We just have to be a little bit careful when we are subtracting negatives because, it's going the opposite direction. When we're doing the power rule, we're so used to things getting lower, dropping in powers, that we sometimes will get negative 2 for this. We just shut our brains off for a second. But this is actually going to be negative 4. Now, I tell my students one of my rules is no negative exponents left in any of our derivatives. So we go ahead and rewrite this as 12 divided by x to the 4th. Because the x has a negative, we drop the exponent to the denominator, the power to the denominator, and make the exponent negative. So power rule has a lot of applications. Nope, I went the wrong way. One of them is with radicals. So we know that the square root can be written as y is equal to x to the half. I want you guys to try this one and then check my comments there. I'm going to have a little video on taking the derivative of a square root. If this video helped you at all, please like, share, subscribe. And thanks again for watching, guys. We stuck around for the whole video. And I'll see you guys in class. Take care.